The sun's heat is beneath our feet. Scientists have figured out that Earth's core is actually as hot as the surface of the sun, around 10,800 degrees Fahrenheit. One of the reasons it's so incredibly hot down there is because Earth is still shedding heat from when it was created billions of years ago. Also, when an object as big as Mars slammed into the young Earth, it not only created the moon, according to one theory, but melted the surface of the planet. A lot of that extra heat is probably still stored inside the core. But there's no need to worry. The planet's core is harder for us to access than it is to probe the surface of Pluto. In fact, chances are we may never develop technology that could physically reach the core. There's no air on the moon. But then, how can it be rusting? Scientists have discovered the presence of hematite on the moon, and it's a kind of rust. A special NASA research instrument examined the light reflected off the moon's surface. It turned out that the composition of the satellite's poles was very different from the rest of it. The moon's surface is dotted with iron-rich rocks, but without oxygen and liquid water, rust can't appear. Solar winds add to the mystery. They bombard the moon with hydrogen, and hydrogen makes it much more difficult for hematite to form. Even though the moon doesn't have an atmosphere, it still has some trace amounts of oxygen. Its source is our planet's upper atmosphere. Earth also protects the moon from almost 100% of solar winds, although not all the time. And even though our natural satellite is bone dry, there might be water ice in the shadowed craters on its far side. A day on Uranus lasts 17 hours, 14 minutes, and 24 seconds. But get this, the planet has a tilt of around 98 degrees, and that makes a season on the gas giant last 21 Earth years. Mars has 2 moons, Phobos and Deimos. In the next 30 to 50 million years, Mars's gravitational forces will tear Phobos apart, and it will likely result in the formation of a ring around the planet. The Earth is the densest in the solar system. At the Earth's center, there's a core that takes up 15% of the planet's volume. It consists of 2 parts, the outer and the inner core. The inner core is a solid ball made of iron and nickel. Its radius is 760 miles, which makes 20% of the entire Earth's radius and 80% of the Moon's radius. The 1,500-mile thick outer core is liquid. It also consists of iron and nickel, but it's not under enough pressure to be solid. Mars houses the biggest volcano in the solar system. While everything seems to be calm on Mars nowadays, in the past, some sort of force caused enormous volcanoes to form and erupt. One of these volcanoes is Olympus Mons. It's 16 miles tall, which is the height of 3 Mount Everests, and 374 miles across, making it about the size of Arizona. The volcano grew to such a gargantuan size because of the weak gravity on Mars and the lack of tectonic plate movement. Gravity is not the same everywhere. The rocks, metals, and other minerals and substances that make up the planet are packed into the ground more tightly in certain places than in others. This has surprising consequences. Gravity varies slightly depending on where you are. You weigh 0.5% less standing at the equator than you do at the poles. In most cases, that's a difference of less than 1 pound. How high up you are also has an effect. So if you were at the top of Mount Everest, you'd also weigh slightly less. Just don't look down. Earth's toughest living thing is so small you can't see it. Water bears, also known as moss piglets, are cute little creatures with 8 legs and squashed up heads that are less than 1/100th of an inch in length. Despite their microscopic stature, they can basically survive anywhere. They prefer bits of wet moss or the bottom of a lake, but they won't complain if you put them somewhere really uncomfortable. They can endure extreme cold and incredible heat, and survive both huge pressure and high radiation. Some of the little bears once even managed to survive unprotected in outer space for 10 days without a problem. That is tough. They handle all these things by rolling up into a ball and hibernating, which reduces their need for oxygen and food. The moon's gravity is about 17% of that on Earth. If you weighed 200 pounds on our home planet, on the moon, your weight would decrease to a mere 34 pounds. You would also be able to carry stuff 6 times heavier than what you can carry on Earth. It would also be easier to walk on the moon's surface, but it would be more dangerous too. Your feet, inside a heavy spacesuit, would sink into the lunar soil up to 6 inches deep. But let's imagine you decided to skip the tedious process of walking by leaping through the air. Then you'd likely lose control of your jumps in no time. Plus, the moon's surface is littered with deep craters. It would be a tough feat to avoid all of them. You can see solar eclipses because even though the moon is 400 times smaller than the sun, it's also 400 times closer to Earth. So it's perfectly capable of obscuring the star. But in 50 million years, I won't be around then. The moon won't be able to block the sun completely because of the satellite's changing orbit. A full NASA spacesuit costs an unbelievable $12 million. Yeah, I can believe that. 70% of this hefty sum is for the control module and backpack. At the very center of Uranus, there's a rocky core, small, just half the Earth's mass. Compared to other planets, Uranus's core is rather cool, 9,000 degrees Fahrenheit. An ice mantle surrounds the solid core, and that's the largest portion of the planet, about 80%. It's also not the ice you might be thinking about. It's a hot, dense fluid made up of water, ammonia, ice, and methane, sometimes referred to as a water-ammonia ocean. Uranus's atmosphere is mostly hydrogen and helium, but it has its blue-green color because of methane gas that absorbs the red light. The ocean on Jupiter is larger than any other in the solar system. But unlike Earth's oceans, it's made not of water, but of metallic hydrogen. The ocean's depth is a mind-blowing 25,000 miles. That's almost the same as the distance around Earth. Venus is a champ when it comes to volcanoes. The planet has about 1,600 major ones, but none of them is known to erupt. There's a supermassive black hole 250 million light-years away from us. It hums the deepest sound ever detected from any object in the universe. It's 57 octaves lower than the middle C on your piano. That's 1 quadrillion times deeper than what we can hear. Mercury is a few billion years old. In 2016, scientists discovered some abnormalities on the planet's surface, showing that it's getting smaller. After more research, they found out that Mercury hadn't finished cooling down yet. There are planets that aren't bound to any star orbit and aimlessly wander through outer space. Among the most spectacular-looking space objects are pulsars. Pulsars are a type of neutron star. They shoot out some of their material almost at the speed of light. Regular pulsars spin at a reasonable speed, between 1/10 to 60 times per second. But millisecond pulsars can spin at an impressive 700 times a second, which is way too fast for the human eye to even process. As they spin, they emit a beam of radiation from their axis that looks like the light from a lighthouse. Astronomers can notice pulsars when they face Earth, since it looks like a light being shined on our planet. When the light shines elsewhere, the pulsar can't be seen. Our sun is insanely massive. Want some proof? 99.86% of all the mass in the solar system is the mass of the sun. In particular, the hydrogen and helium it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. Saturn's rings are very thin compared to its size. If you had a scale model of the planet that was 3 feet wide, the rings would be 10,000 times thinner than a razor blade. Even though Venus is the hottest planet in our solar system, it still has snow. But not what you'd expect. It snows metals and rains acid. Not a great vacation spot.
Consider the rogue planet, the cosmic wanderer that nobody wants to take home. Basically, a rogue planet is a planet that has been ejected from its own star system and is now floating aimlessly through space like a cosmic loner. These planets aren't just a theory. Scientists have actually detected some in our galaxy. In fact, estimates suggest that there may be lots of these cosmic nomads floating around the Milky Way. And they aren't just small rocky worlds like Earth. Some of them are actually massive gas giants, many times larger than Jupiter. These behemoths could potentially have their own moons, and even their own mini-systems orbiting around them. For example, one of the most famous rogue planets we know of has a complicated name. Here, you read it for yourself. It's located about 80 light-years away from Earth, and it was discovered in 2013. This rogue planet is estimated to be around 6 times the mass of Jupiter, and is believed to be around 12 million years old. And yes, just because these cosmic loners don't have a star, it doesn't mean they're super cold. They can still generate heat and light from their own internal processes. Some may even have magnetic fields and auroras, just like Earth. In other words, rogue planets could potentially be habitable if they have the right conditions. So, what would life on such a planet look like? And could we potentially live in such a world? Well, living on a rogue planet can be a lonely existence. They have no warm sun to bask in, no cozy atmosphere to cuddle up in, and no cosmic neighbors to have barbecue with. That's why we'd have to get creative. Let's start with the most obvious problem. We'd have a hard time without light and heat. So, how do we fix this? Well, we'd probably have to invest in some really fancy space heaters and wear fashionable super-warm spacesuits. Or we could invent a whole new way to generate electricity without relying on solar power. For example, how about using geothermal energy? Now that's hot stuff. Each planet has an internal source of heat. Without it, they would all be nothing more than cold, lifeless rocks floating through space. This internal heat can be harnessed and used to power everything, from homes to factories to spaceships. It's like having a hot tub big enough to power an entire city. And that city, most likely, will be located underground, closer to the heat source. And as for light, well, we'd probably have to build some really bright flashlights. Or maybe even learn to genetically engineer some bioluminescent organisms to light up our homes. Just imagine, space is overgrown with neon mushrooms and plants. By the way, speaking of plants, plant life would be pretty hard to come by without a star. So, what would we eat? Well, we could use the same geothermal vents that we talked about, or some chemical reactions to sustain ourselves. And hey, maybe we'd develop a taste for sulfur-rich foods, or we'd start fermenting our own drinks from the bubbling volcanic mud. Yum! But besides food, we'd have a more important problem. Living on a rogue planet would be breathtaking, literally. We'd have no air. You see, not all rogue planets have good, stable atmospheres. It all depends on their size, composition, and other things. But even if our new home does have an atmosphere, it may be incredibly thin and unstable. We'd have no pretty blue skies or dramatic sunsets to admire. Instead, we'd be staring out into the infinite void of space, where the stars would be brighter than ever before. And forget about weather patterns. Without an atmosphere to create them, we'd have no rain, no snow, and no thunderstorms. And that's just some minor problems. What's worse, the temperature on the planet would be wildly fluctuating, swinging from unbearable heat to unbearable cold. It would be like living in an oven that's always being turned on and off. And finally, we'd be exposed to all kinds of space debris and cosmic radiation. So, if you don't want to get crispy, you might want to invest in some serious SPF. So, how do we fix it? Well, we'd have to find a way to generate our own oxygen and probably create something like a space-age biosphere. For example, we could grow some plants that could produce oxygen, or we'd learn to filter the air like a high-tech air purifier. Finally, we have the last most important problem, finding water. And here's where the underwater oceans come to our aid. Now we're really diving deep into the possibilities. Nyuk, nyuk. But seriously, scientists suggest that some of these planets may indeed have underwater oceans. It would be like living on a giant water balloon that's been buried underground, with the ground beneath your feet made of ice and rock. In other words, we could just tap into these underground oceans. They could provide us with a source of water for drinking, farming, and manufacturing. Maybe even with some other resources and materials we've never seen before. And by the way, who knows what kind of strange creatures might be lurking in those underground seas? But don't worry. Even if we don't have any underground oasis, there are also other options. We could get some water from comets, ice mining, and even from the atmosphere, the one we just created before. Finally, we need to find and mine some resources to build our homes and other stuff. And a rogue planet might not have the same kinds of resources as a planet that orbits a star. It's like trying to find some treasures in a desert, not exactly a sure thing. We may have to rely on resources from nearby asteroids and things like that. And if we want to extract resources from the planet itself, we might need to drill down through miles of ice and rock. But hey, if you're up for the challenge, there'll always be a chance you'll strike it rich on a rogue planet. And who knows, maybe you'll discover some new resources that are even more valuable than gold or diamonds. Great! Looks like we've solved the most important problems. Now, there may be other small difficulties. For example, we'd also have to deal with some seriously long days and nights, depending on how fast our planet was rotating. And we wouldn't have a normal, regular day-night cycle. The rotation of our planet could be wildly unpredictable. Maybe we'd have weeks-long nights, followed by weeks-long days, which could really mess with our sleep schedules. We might have to develop some really strong coffee to keep us going through those long, dark nights. But, hypothetically, we can adapt to all these things and overcome all the challenges. And now, finally, welcome to the rogue planet, where the sun never rises, but the adventures never end. Thanks to our advanced technology, we've managed to create a comfortable and habitable environment in this once barren world. The sky above us is now a beautiful shade of blue, filled with fluffy white clouds and the occasional flock of flying creatures. Don't ask. As we venture out from our underground habitats, we're greeted by a world that's full of surprises. Strange plants and animals have adapted to the unique conditions of this planet, some with bioluminescent features that glow in the dark. And be careful if you want to go swimming in the underground ocean. They might be home to some bizarre creatures who want to feast on… well, we'll come back to that. Maybe. As you can see, we've created sprawling cities and thriving communities, powered by the planet's geothermal energy. We also created a bunch of artificial light sources that keep things bright throughout the dark, chilly nights. Of course, we still have some problems with navigation and timekeeping, but things aren't as dull as they used to be, are they? Overall, living on a rogue planet would definitely have its challenges, but it could also be a pretty exciting way to experience the universe. And who knows? Maybe someday we'll find such a planet and actually turn it into a bustling intergalactic metropolis someday. But until then, let's enjoy and tidy up our dear Earth.
Arcturus, a huge red star. It's just bursting from inside out. The red sea of plasma on its surface rages and pulsates. The star burns anything that comes close to it. And now, plop! Arcturus is gone. But at the same moment, it reappears at the center of our solar system, replacing the sun. What we see in the sky isn't a small yellow dot anymore, but a giant red ball. It's 25 times wider and 30% heavier than the sun. Even though Arcturus is a little cooler, it's still a total nightmare for Earth. The distance from our planet to the star is now 25 times less. All the water in the oceans and rivers begins to evaporate. What used to be rainforests are quickly turning into a lifeless desert. But sunsets and sunrises now look amazing. Imagine yourself on the roof of the Empire State Building, watching the sunrise. First, you see the light over the horizon. It almost blinds you because Arcturus is 110 times brighter than the sun. Then, the star gradually climbs over the surface. The thick dot on the horizon gets wider and wider. It continues to grow until the red star is everything you can see. Arcturus is now so close that you can even see storms of hot plasma on its surface. there are periodic outbursts and mass ejections. Huge amounts of matter are ejected from the surface of the star at speeds of up to 1,200 miles per second. The matter takes the form of a loop attached to the star at both ends. And you have to wear a super advanced spacesuit to be able to observe such a sunrise. Life on Earth ceased to exist long ago under these conditions, and it's going to get worse over time because every 8 days, Arcturus's brilliance increases, and soon our planet will become more like Venus. It's so close to the Sun that the high temperature makes any life there impossible. Okay, let's let our planet cool down a bit and put Proxima Centauri in the center of our solar system. It's not a red giant, but a red dwarf. This star is almost 7 times smaller than the Sun and almost 9 times lighter. Now our oceans and rivers are not evaporating, but freezing over. Forests and jungles are covered with snow. In about a week, there won't be a single place on Earth where the temperature is above freezing. Even plants that are used to the cold will cease to exist. They mostly feed on the sun's energy. Now, they begin to starve. But there will still be water deep beneath the ice layer. It'll be heated by the hot core of our planet. Microorganisms will still be able to survive. It's much darker on Earth too. It's like an endless twilight here. Oh, and we can barely see the moon. The thing is, it doesn't produce its own light, but reflects it from the bright sun. With Proxima Centauri instead, the moon will lose its brightness.
Hop on the bright side of life together with our brand new tees, hoodies, and more. Click the link to pick your choice.
But an even bigger problem would be with our orbit. The sun has a certain gravitational force, and it keeps us just in the sweet habitable zone, where we're not too hot and not too cold. Proxima Centauri's gravity is much weaker, and Earth is slowly drifting away from the star. We now run the risk of encountering asteroids flying through space, or even other planets. But the worst-case scenario is if Proxima Centauri simply can't hold our planet, and we fly away into dark space. Then, you can forget about any forms of life here. Now, let's put Sirius at the center of our solar system. It's the brightest star in our night sky. It's only 70% bigger than the Sun, but almost twice as hot. So its glow is not only bright, it's sizzling. And its light is not yellow, but somewhere between blue and white. You couldn't go out in the city without sunglasses, or Sirius glasses. Still, you wouldn't want to walk the streets, where the asphalt is boiling anyway. You could literally fry eggs on the curb. Of course, by this time, all life on Earth has long since disappeared. But it's not just because of the temperature. Sirius emits enormous amounts of radiation. Our atmosphere serves as a shield against the sun. But in the case of Sirius, that shield wouldn't be enough. Now, why don't we take a more bizarre approach and make ourselves a double star system? These are 2 stars that revolve around a common center. And there's our Earth, safe and sound. It's all about the size and brightness of the stars. These 2 aren't too big, and they give off as much light as our sun. All that matters to us is that our planet is in the safe zone of the double star system. At sunrise, you first see one star appear from below the horizon, and then, a couple of minutes later, the other. The only problem is that this beauty may soon explode with enormous force. In binary systems, one star is always heavier than its companion. Sooner or later, it starts pulling matter away from the smaller star. Gradually, the bigger star just eats its neighbor. Then the big brother can reach a critical mass and explode. This explosion would be about as strong as a supernova. It would destroy our entire solar system. The light from this explosion would be visible for hundreds of light years away. And after that, there would be a huge nebula in the place of our star system. It's stardust and particles that are left from our world. Going to the realm of the crazy now, a black hole. Yes, there's one at the center of our solar system now. We know black holes are scary, mysterious objects that pull in everything in their path. But even around a black hole, there is a habitable zone. You just have to be far enough away so that it doesn't drag you down into its black abyss. Mercury and Venus would be too close to the black hole, so most likely they'd be torn apart and then head for the event horizon. This is the last stop before hitting the singularity, the heart of the black hole. There are only two problems: light and time. A black hole pulls light in instead of emitting it, so the Earth will quickly become dark and cold. And time goes slower around heavy objects. Near a black hole, 1 second can be equal to weeks or even months away in outer space. We won't feel this difference, but the entire universe around us will develop faster relative to us. Any object can become a black hole if it's compressed to a certain size. For example, the Sun can become one if it's shrunk to a width of 3.7 miles. And even the Earth, if you squeeze it to a width of 0.7 inches, it becomes a black hole. Oh, now there's some little rock lurking in the center of our solar system. It's a neutron star. It's about 18 miles wide. Some meteorites are much bigger than that, but it has a mass comparable to the Sun, so its gravitational force is about the same, and our planet's orbit is intact. But the problem is that neutron stars emit next to no visible light, so it's now permanent night on Earth. Still, it gets very hot here. When a neutron star is born, it can be several times hotter than the Sun at first, but it quickly cools down to the temperature we're used to. So there's a chance that all life on Earth hasn't yet been scorched. Another problem is that these little guys are rapidly spinning and can become pulsars. It's kind of like a powerful spotlight on two sides of a spinning star. Neutron stars also eject radiation at tremendous speeds. These rays will make our planet literally sterile. No life form would be able to exist under these conditions. And now, it's time for the biggest star ever known, Stephenson 218. This red giant is 2,150 times larger than the Sun, and if we place it at the center of our solar system, its edge will lie on Saturn's orbit. So Mercury, Venus, Earth, Mars, and Jupiter are already swallowed by the huge star. Saturn, Uranus, and Neptune are roasting like chestnuts on a fire and will soon evaporate. In fact, this could happen to our Sun as well. The older it gets, the redder and bigger it becomes. It'll eventually run out of its fuel, hydrogen, and the Sun will start to burn heavier elements in its core. This will cause it to expand. Then we'll see more beautiful sunsets and sunrises, but the temperature will become too high. In theory, the Sun will get so big that it'll swallow the Earth, and then it'll explode in a supernova, leaving nothing of our entire solar system behind. Shiny!